Hi students, welcome back to geology. This module we're talking all about the atmosphere, so this is going to include learning about the layers of the atmosphere, the reasons that we have seasons, and then learning about extreme weather. Okay, so first we're going to start with what is the atmosphere. So the atmosphere is a layer of gases that basically blankets Earth. So it protects us from a lot of different things. It helps burn meteorites up so that we don't have as many meteorite impacts. It helps protect us from solar rays. And it mostly consists of nitrogen and oxygen, although a lot of people have the misconception that most of the Earth's atmosphere is oxygen. Actually, about 78% of the Earth's atmosphere is nitrogen, which is important to have in addition to oxygen, which is 21%. So we do have oxygen in there, which is what we breathe. And then there's a myriad of other components as well, including carbon dioxide, argon, water vapor, of course. And it's really important to have nitrogen because it helps with plant and growth and development. So if we didn't have nitrogen cycling through our atmosphere by being absorbed by plants and other vegetation and then recycled back up into the atmosphere, we wouldn't have the plants producing the oxygen that then we can breathe. And then carbon dioxide is a little important because that's also what plants use, right, to grow. So the breath that we release is carbon dioxide, and when we exchange that with plants, it helps not only us, but also the plants. While we do see a huge spike in carbon dioxide in the last 50 years or so, that is also helping to warm our planet with greenhouse gases. There is a small component of the Earth's atmosphere that needs to be carbon dioxide to help other systems operate. All right, so within the lowest layer of the atmosphere, we do also see some other variables that are kind of clouding up the atmosphere, if you will. So we do have a little bit of water vapor. It's only about 4% of air's volume, so it's not a lot, but it helps form our clouds and our precipitation, and it absorbs heat energy from the Earth. Okay. And then we do see aerosols, which could be natural or unnatural. So these are any kind of tiny solid and liquid particles. If you're not familiar specifically with what an aerosol is, just think of a can of hairspray or a can of spray paint. Those are aerosols, and they do have solid and liquid particles that get dispersed into the air. And the problem with aerosols is they reflect sunlight and they cloud up our atmosphere. So this photo here shows you aerosols in the air, and these can come in a lot of different forms. They don't have to be any particular constituent, but they do cause a lot of issues. One of those issues is ozone depletion. So one of the aerosols that we have seen in the last 100 years or so go into our atmosphere a lot are chlorofluorocarbons, or CFCs, and these have been depleting the ozone, which is a layer in the atmosphere that consists of 3 atoms of oxygen. And so it's an O3 layer, which isn't necessarily something for us good to breathe, but it's so far up in our atmosphere that it's not going to be within our breathing range. And the reason that the ozone layer is important and we want it to stay is because it helps protect us from excess UV radiation. And so what that means is if we have too much UV exposure, it can burn our skin, right? So if you go outside and you don't wear sunscreen and you're exposed to the sun for a long period of time, you'll get sunburned, right? So it's the same situation, but just if this ozone layer wasn't around the Earth, blanketing the Earth, we would have even more extreme sunburns when we were exposed to the sun. But the good news is we've been able to repair a lot of the ozone hole that we were seeing in the Antarctic region or at the South Pole. So in 2001, that shows you an image of what the depletion looked like, and now we have started to recover that, and We are emitting far less CFCs than we were previously. All right, looking at the layers specifically. So the first one is troposphere, which is the closest to the Earth. And then we get into the stratosphere, the mesosphere, thermosphere, and then the exosphere. So the first one we'll look at is the troposphere. So this is the lowest layer. This is where we breathe air. This is where weather occurs as well. Once you get towards the outer boundary, which is around 12 kilometers from the surface of the Earth, that is the line where we call the tropopause. So it's kind of a pause between layers. You can also see planes traveling in this layer, hot air balloons. A lot of what we do as humans occurs in the troposphere. So that is the first layer. Second layer is the stratosphere. So that goes from 12 kilometers to 50 kilometers above Earth's surface. And this outer boundary, once you get closer to the mesosphere, is called the stratopause. This is also where the ozone layer is. So 12 to 50 kilometers away from us, right? So we don't necessarily have to worry about all of that excess oxygen there. And again, the ozone layer shields us from excess UV radiation. And then we can also collect data from this layer using radiosondes, which is what this is pictured here. And it gives us lots of information about temperature and weather in the lower portion and things about the ozone layer. Then we get into the mesosphere, which is the next layer, which is 50 kilometers to 85 kilometers above Earth's surface. Again, at the top of this, as you go into the thermosphere, there is a boundary known as the mesopause. And this is an area where we have really thin air, low atmospheric pressure, and it's also the layer where most of our meteors trying to enter Earth will burn up. So they will kind of disintegrate in this area, in this layer, and then depending on their size, may or may not actually make it to impact Earth. All right, then we get into the thermosphere, which is the fourth layer, and it is 85 kilometers to question mark. So there's not a clear upper defined boundary, and it kind of shifts a little bit as you go around the Earth. But temperature is increasing here because we have gases that are moving at really high speeds because the pressure is so low. So as you move away from Earth's surface, the pressure moves lower and lower. So as you get to the thermosphere, the pressure is so low that particles are really far apart and can move a lot faster. And so we see a temperature increase there as it goes from that medium pressure to that lower pressure. This is also where you can see the northern lights or the aurora borealis. And there's a beautiful picture of them right there. After the thermosphere, we get into what we call the exosphere, which is technically space. This is the closest space to our atmosphere where we put a lot of our satellites. So the exosphere is where you are exiting Earth and you're really no longer part of Earth anymore. You're part of space. And we do have the International Space Station there, some satellites, and this is where we do a lot of monitoring outside of Earth. Looking at temperatures, I talked a little bit about temperatures and pressures. Remember, pressures are decreasing, and so are temperatures as you move into space. But within each layer, there are trends that temperature is changing. So within the troposphere, as you move up through it, you are decreasing in temperature. In the stratosphere, you're increasing in temperature because of the ozone layer. So in the stratosphere, the ozone layer is absorbing a bunch of sunlight, which is heat, right? That's heat energy. And that heat energy is going to increase the temperature. So in that layer, the temperature increases because of the ozone. And then in the mesosphere, we see a decrease in temperature again as you're moving away from Earth. And then in the thermosphere, like I said, the low pressure starts to increase temperature until you're into space. And we see a decrease again. All right, so why do we have seasons, right? So depending on where you live, you may have 4 seasons or you may have less, right? In Fresno, we technically have almost 4 seasons. 2 of them get kind of overshadowed, it seems like, between summer and winter. Our fall is maybe a week or 2, month if we're lucky, and then it goes straight into what we would consider winter. Maybe other people would consider it fall. And then in our spring, same thing. It almost seems like we only get maximum about a month of actual spring, and then we transition right into summer. So, but in general, we do have 4 seasons, right? Summer, fall, winter, spring. And we will talk about why we have them. So the main thing is that we have a rotation that is inclined. So Earth is not sitting on a top straight up and down. It is inclined at 23.5 degrees. It rotates around itself and then around the sun. And that tilt is what helps us have seasons. So when we're tilted away in the northern hemisphere, it's winter. When we're tilted towards in the northern hemisphere, it's summer. And so depending on where the Earth is in its orbit around the sun, it will either be tilted away or toward. And so what we generally look at is the angle of the sun's rays. So are the sun's rays hitting 90 degrees, or are they hitting a larger number than 90 degrees? And so if the sun's rays, solar ray, is hitting the Earth at a 90-degree angle, it's going to cover a smaller area, and that's going to increase temperatures. Okay, but if it hits it at a different degree than 90 degrees, if it's lower or higher, then it's going to cover a much larger area, and that's going to dissipate the sun's heat energy on the Earth, and that's going to create lower temperatures. And so in general, in the spring and fall, we see the sun hitting the equator at 90 degrees, which gives us a moderate temperature. But in the summer, when we're tilted towards the sun, we tend to see 90 degrees hitting at 23.5 degrees north latitude, which is really close to where the Central Valley sits. It's a little bit south of where we sit. It's about in Mexico, but it's pretty close to where we are. That means that we're going to get hotter temperatures in the summer months, right? When we're tilted away, so on the right-hand side here, the sun's rays are vertical or at 90 degrees at 23.5 degrees south. So the southern hemisphere is now in summer, but the northern hemisphere is in winter. And so looking at the direction of the tilt and then the angle in which the sun's rays are at 90 degrees hitting Earth, that's how we tell when we have which season. So here's another look at that, showing you on a map, not just the globe, where the light hits at 90 degrees in summer, winter, and then spring and fall. So like I said, spring and fall is at the equator, so 90 degrees at the equator, and then summer is going to be 23.5 degrees north, and winter will be 23.5 degrees south. So when the sun's rays are specifically at the 23.5 degrees south latitude, that's what we call the winter solstice, or when we consider it finally winter. Same thing with summer. When the sun's rays are 90 degrees finally at 23.5 degrees north, that's when it's technically summer, or we have the summer solstice. So that's where those delineation comes from. And then in spring, it's usually around March 22nd is where the sun's rays are finally at the equator again. And then in fall, it's usually around September 22nd, and that's when the sun's rays are at the equator again. All right, other things that control temperature are land versus water. So if you live next to water, you are going to have a much more temperate experience than if you live inland, because land heats and cools more rapidly than water. Water, especially if it's a large body of water like the ocean, tends to keep a fairly consistent temperature year-round. And so it's really hard to heat and cool and change the temperature of that large mass. Land is much more susceptible to temperature changes. So that's why in the Central Valley, we can go from 20 degrees to 120 degrees in the summer. We have a very big difference, but you go to San Francisco, or you go to the coast somewhere, it's about between 60 and 80, no matter what time of year it is, right? They're much more temperate. They stay fairly consistent. So these two descriptions, or these two graphs here, show you Vancouver, which is on the coast, and Winnipeg, which is inland, showing you the difference in temperature throughout the year. Altitude also changes temperatures, right? So if you're at a high altitude, you're higher in the troposphere. That means that you're going to have cooler temperatures. So higher elevations tend to have a lower temperature, and then lower elevations tend to have a higher temperature. So here, there's two examples here, La Paz and Concepcion, but you can also think of Fresno versus Shaver Lake or Yosemite, right? In Yosemite, it's a higher elevation, so their temperatures are usually lower. In Fresno, our temperatures are usually higher because we are at a lower elevation. So scientists put together sea level temperatures in these maps. These are isotherms, so the lines that are running horizontally across the map are what we call isotherms, and they are just areas that connect temperatures. So it's kind of like a topographic map, but it's looking at temperature instead of elevation. And so when you look at these, you can see in January, the hottest temperatures are at that 23.5 degrees south latitude. And in July, in summer for us, you see the 23.5 degree latitude is where all the hottest temperatures are. And so one of the things that you want to pay attention to here is that there is variation depending on where you are on the globe, what the isotherms are doing. So can you notice any trends? So if you don't notice any trends, the big thing that you want to pay attention to is that the isotherms in the oceans are fairly consistent. They're fairly horizontal. But when you go over land, they start to bend and curve and change a lot, right? And so that just kind of further shows that water stays a fairly consistent temperature, but it's land that's changing a lot more drastically. All right, so that is our layers of the atmosphere and our reasons for the seasons. The next lecture we're rolling right into in the same module is going to look at weather system fronts and hurricanes and all of that fun stuff. So I'll see you guys in the next video. Bye.